Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module, problem number 21. Fluid mechanics, problem number 21. Okay. As usual, we first come towards statement. An office window has dimensions 3.4 meter by 2.1 meter. So here, while determining the area, we will assume one of these two parameters as length and other as height. Okay. An office window has dimensions 3.4 meter by 2.1 meter. As a result of the passage of a storm, the outside air pressure drops to 0.96 atm, that is atmosphere, but inside the pressure is held at 1.0 atm, that is atmosphere. What net force pushes out on the window? We have to find out net force. While two pressures are given, okay, one is the pressure inside the room and the other is outside, okay. So dear students, when net force comes under consideration, then definitely net pressure comes under consideration. So we will take one of these pressures as inside pressure, which we will denote by I, and the other by outside pressure, denoted by O. Okay, and net pressure will be inside pressure minus outside pressure. Okay, so now we move on to solution. Okay, solution. Let Pi, where I is written as a subscript of P, let Pi equal to inside pressure is equal to 1.0 atm, atmosphere. Okay, while P naught, here dear students, we will not read it as P naught, rather we should pronounce it as PO, because here inside and outside pressures are under consideration. So here Pi, and instead of P naught we should designate this symbol as PO, outside. Okay, inside pressure Pi equal to 1.0 atmosphere atm, and outside pressure PO or P naught, PO equal to outside pressure is equal to 0.96 atm, atmosphere. Okay, hence net pressure will be equal to initial pressure minus inside pressure. Okay, net pressure equal to inside pressure minus outside pressure, equal to 1.0 atm minus 0.96 equal to 0.04 atm. Okay, we know from table of conversion factors regarding pressure. Okay, we know C table that 1 atm, that is 1 atmospheric pressure, 1 atmosphere is equal to 1.013 into 10 raised to the power 5 Pascal. Okay, here we see that table. This is the table. Okay, dear students, here we can see that 1 This is 1 atm, 1 atmosphere, 1 atmospheric pressure. Okay, 1 is equal to 1.013 into 10 raised to the power 5 units are Pascal. Okay, 1 atm is equal to 1.013 into 10 raised to the power 5 Pascal. Okay, so what we have said, we know C table that 1 atm is equal to 1.013 into 10 raised to the power 5 Pascal. This implies that, okay, what we have earlier said, that net pressure is equal to 0.04 atm. So now in place of atm we will use this value. Okay, this implies that net pressure is equal to 0.04 into 1.013 into 10 raised to the power 5 Pascal. After simplification, this becomes equal to 4052 Pascal. That is 4053 Pascal. Okay. We can also write this quantity as 4.052 kilopascal. Okay, or we can write it as 40.52 into 10 raised to the power 2 Pascal. Okay, or 405.2 into 10 raised to the power 1 Pascal. So okay, so these are just matter of discretion. We are not bound to discuss these minute things. Okay, now we come towards further solution of this problem. Okay, and we start as usual in our previous modules on this topic. Okay. We know that the pressure P in a fluid is the force per unit area exerted by the fluid on a surface. That is P, three horizontally parallel lines which are read as pressure is defined as force over area, force per unit area. Equation number 1. Okay. In the SI system, pressure has units of newtons per square meter, that is capital N over small m square, that is Newton per meter square, and 1 Newton per meter square is equal to 1 Pascal, denoted by PA. Moreover, 1 Pascal is equal to 1 Newton over meter square, as already discussed, and then this is equal to kilogram per meter second square, and this is alternatively equal to joule per meter cube. Okay. Now we move on to next part. Okay. Using, dear students, because we are given two pressures, and from there we have found net pressure. Similarly, force F will be replaced by F net, that is net force. Okay, because pressure is net, so force exerted will also be called net force. Okay, using P equal to P net, where net is written as a subscript of P equal to net pressure is equal to 4052 Pascal, and F equal to F net equal to sign of interrogation, that is force or net force is yet to be determined. Okay, we have to find out the net force. Moreover, area A in the denominator, this A is equal to, area is equal to length into other dimension. Okay, length into height. So area will be equal to 3.4 meter into 2.1 meter equal to 7.14 meter square. Okay, because dear students, we know that area is always expressed in meter square or centimeter square x. That is to say, area is a two-dimensional quantity while volume is a three-dimensional quantity. Okay, volume is equal is expressed in meter cube or centimeter cube. Okay, moreover, in equation number 1, we had used these three horizontally parallel lines which are read as is defined as. So here it is described that this symbol and this symbol are equal or equivalent. Okay, we can use sign of equality in place of this sign. Okay, because this is read as is defined as, so this symbol is equal to sign of equality. Okay, in equation number 1 we get 4052 Pascal is equal to F net over 7.14 meter square. This implies that net force will become equal to this multiplied by this. Okay, 7.14 meter square will be multiplied with 4052 Pascal. Okay, and hence this implies that net force is equal to 4052. In place of Pascal, we have used its alternate expression, that is Newton per meter square. Okay, because we know here we have described that 1 Pascal is equal to 1 Newton per meter square, and alternatively Pascal equal to 1 kilogram per meter second square. Okay, so here in place of Pascal we have used Newton over meter square. So from here meter square will be cancelled out with meter square and net force will become in Newton. Okay, this implies that net force becomes equal to 28,931.28 Newton. We have reached our solution. Okay, we do not need further to express this quantity in other forms. However, we can write this term as 28.93128 kilonewton or 2.893128 into 10 raised to the power 4 Newton. Okay, so this implies that net force is equal to 28.931 kilonewton, and if we further divide by 10, then this kilo will be elevated to one step ahead, that is 10 raised to the power 3 will become 10 raised to the power 4, and this quantity will become 2.8931 into 10 raised to the power 4 Newton. Okay, and this is the proper solution of our problem. This table we have already shown. Now we come towards the reference. Okay, reference book from where this problem has been chosen. Reference book is Fundamentals of Physics Extended. Authors are Holiday and Resnick. Journal Walker. Publisher is Wiley. And its 10th edition 2014 or 11th edition having been published in 2018 has been adopted or followed. And here chapter number 14 under title Fluids is our concerned chapter, and our concerned problem is enumerated at serial number 5 of the exercise given at the end of this chapter, and this is the end of our module, our problem. Okay.